Now let's get into some of the terminology related to containers. The first is the term image. When we're talking about these computing environments called containers, they are instantiated based on the instructions contained in an image. So you can think of the image being a sort of template from which we create containers that have certain features because the image said that they should have them. So images are the stuff from which containers are made. If you think about this in comparison to object-oriented programming, you could think of a container as being an instance of what the image represents, an instance of that class that the image defines. Of course, it's not object orientation exactly, but it's a similar kind of a concept, at least for class-based object-oriented programming. So what we would do is we would design an image and then use that image to instantiate as many containers as we want from that image. Where do we put our images? We often share them with other people by posting them to a registry. So for example, Docker maintains a registry called Docker Hub, which is hub.docker.com. And if you wanted to poke around and look at what images other people or other organizations have made and are sharing with the world, you can come here and search. So for example, the MongoDB organization makes several container versions of their technology. So for example, MongoDB Community Server is a kind of a free version of the MongoDB database for regular people. And there's a containerized version that they post here. This is the image. This is the page for the image that they make. That is, again, the template from which you can instantiate containers. So that's how containers work. If you remember, they're instantiated from images. So you could download this image to your own computer and then instantiate it into containers, as many different MongoDB instances as you wanted. The command to do that in Docker, if you had Docker installed already, would be docker pull and then the name of the image that you wanted to pull. That would download this image to your own machine. Wouldn't instantiate a container from it yet. That would be the docker run command, which we'll see later. So this is a place where you can search. And of course, there is a user called Bloombar who has a container image called se_welcome. That's me. And this is a image that I've posted to Docker Hub just as an example of a simple one to use as an example. So you could get that onto your own machine by doing docker pull, then again the image name. Usually we talk about images as the account name / the account that created them / and then the name of the image. How do you get Docker so that you can do this? Well, you would want to install a tool called Docker Desktop if you're using this on your own personal computer. Docker Desktop is your preferred download. So just go to that website, Docker Desktop, create an account, download, install it. It's just a regular software you installed on your machine. And then you have Docker running. All right, so that's the registry. You can create an account on Docker Hub. You can download the Docker Desktop, have it installed on your own computer, and start to download images. And as we'll see, instantiate containers from them. All right, I'm going to skip over security and just go into how you would then start to use them. The basic way you would run a container, which again means instantiate a container from an image, would be the docker run command. So docker run, you can give a container that you instantiate a nickname. So this could be -- name, and then whatever name, you replace this with whatever name you want to give it. It's a nickname that you can refer to it by later. You don't have to do this option, but it's just nice to, sometimes you have multiple instances of the same image, and so you want to give each container its own custom name to differentiate them. -ti means that input from your keyboard will be forwarded to the container, and output from the container will be forwarded to your terminal. So this just allows simple text input to the container and text output from the container to be forwarded to and from your own personal computer. Remember that the container considers itself to be its own computer, right? It is acting as if it's a full computer, even though we know it's virtual. And so keyboard input you type on your keyboard is being typed on the host machine, not on the container. So this actually forwards that text input to the container. So it seems as if the keyboard is sort of attached to the container. Same with output. When there's text output to the system output of the container, that would normally just output to the command line of the container, but using the -ti will allow you to have that forwarded to the text output on the command line of your host machine. So the system output of the container gets mapped out to the system output of the host machine. All right, and then you have the image name. This is the template from which the container is going to be made. So bloombar/se_welcome, for example. So you can run this on your own terminal. You can create a runnable container with docker run, give it a nickname, --name, foobar baz bum, and then you specify that you want input and output forwarded to and from the container from your host machine, and then the name of the image, bloombar/se_welcome. So once I hit enter, the Docker technology is going to do two things. It's going to first check, do I have this image on my own machine? If I have already downloaded this image, perhaps with a docker pull command, then it has it and it'll just launch a container from it. If you don't have it on your own machine, it'll download it for you. So it'll actually do a pull first and then execute a container, instantiate a container from that image. So I do not have this on my machine. So I'm going to hit enter. You're going to see it's going to check if it's on my machine. It's going to say it's not. It's going to download it from Docker Hub and then instantiate a container from it. Here we go. Unable to find the image. And so it's pulling from Docker Hub automatically. Downloading all the parts of this image, and then it's going to instantiate a container from it. All right, and here it is. The container has been instantiated, and this is what happens when this particular container gets instantiated. This container is designed by me to print this out. It actually is running a Python program that prints this out. And there's a menu asking me what I want to do. I can view the Docker file that I used to create this image, or I can view the contents of the Python script that is actually what is printing this text out. So I'm just allowing you to quickly, from the program itself, view the Docker file that was used to create the container, or view the Python script that is actually running right now. So I'll just look at the Docker file. The Docker file is also located in version control. There is on GitHub, under the NYU Software Engineering SE- not underscore dash welcome repository, you can actually look at the Docker file and the Python script that are being used here. But let me use the program itself just for fun. So if I view the contents of the Docker file by pressing 1 and hitting enter, you'll see what's in the Docker file. Now, what is a Docker file? A Docker file is a build configuration script that is used to tell Docker how I want this image to be built from which this container was made. We don't normally see the Docker file from a program running in the container. This is just for example purposes, but this is nevertheless the file that I used to create the image from which this container has now been instantiated. The first line here is typical. It's not always the exact same, but the idea here is that I'm basing my image on another pre-existing image. So the Python organization publishes an image on Docker Hub called Python, and I'm using the version of that image, the 3.5.9 version. And that means that my image that I'm designing in this Docker file is going to be a replica of the Python 3.5.9 image, which itself is based on other images. I believe it is based on a Alpine Linux image. And so I'm getting whatever the image was for Python, plus any changes I make to it in further lines here. The first thing I'm doing is setting the working directory in this image. So the image is going to have a file system. And I'm saying set the working directory to be a directory called /welcome at the root level. Make a directory called welcome. That's going to be the root, the working directory that I'm going to work with. And this means copy all the files from my host machine's working directory into the images working directory. So again, the images working directory is going to be this /welcome in its own file system in the virtual environment of the image. And I'm saying copy from my local working machine working directory all the files into the container, or sorry, the images working directory /welcome. And the next line, which is the last one, is optional, but it's an instruction of what to do when a container is launched from this image. So here I'm setting the image to know when a container is instantiated from this image, run the command python space welcome.py. When you use this setting of a Docker file, you can't just write python space welcome.py. It wants you, the Docker file syntax wants you to write commands like this, but it will ultimately run the command python space welcome.py. So it'll use Python to run the program welcome.py. How do I know Python is installed and will work? Well, I've based my image on the official Python image version 3.5.9. So if Python is going to be a command that is available in this virtual computing environment for sure. And so when I instantiated this container, as you saw, I ran this program automatically. That's because of this line right down here. That's what that did. All right. I'm not going to show you the contents of the Python script because that's just a regular Python program with nothing fancy that just prints this stuff out. So you can look at that if you're interested in it. I'm going to type 3 exit and be done. Okay. So going back to the slides here, we've got the ability to run a container. If it's not available, if the image from which it needs to be instantiated is not available on your own computer, it'll automatically pull it from Docker Hub by default and then instantiate it onto your own computer. There are ways to do additional settings on the Docker run command. Let me just give you as an example. If I had run it like I did before, but then added space bash, it's actually not going to run the Python script. This is going to override that setting of what to do when a container is instantiated, and instead just run the command line bash, which is in any Linux machine or Unix machine, or at least is often the default command line interpreter. So if I hit enter, it's not going to run the Python. I already have a container called foobar-bash-bomb, so I can't make another container with the same name. I apologize. If I do docker ps, you'll see this just shows me any currently running containers. You'll see it's blank. There are no currently running containers. But if I do docker ps-a for all, it will show me there's actually still a container in memory. It's just not running right now. So you'll see it's exited about a minute ago, and the name it had was foobar-bash-bomb. So if I wanted to make another container with that same name, I would have to delete this one. Every container has a certain ID as well as the nickname that you may have given it. And you can do docker rm and then either the nickname or the container ID. Either one works. That's going to remove the container from memory. So that will work. If the container is stopped, it'll remove it. So if I do docker ps-a again, there are no containers in memory anymore. And now I can do what I wanted to do before, which is run one again, call it foobar-bash-bomb, and